Good evening, dear students and viewers. Today we are going to solve one problem in mechanics. The topic is friction. The problem is like a classical problem where we have two masses m1 and m2 placed on an inclined plane as you can see on the screen. M1 and M2 are connected by a string. The coefficients of static frictions are mu1 and mu2 respectively, where mu1 is less than mu2. We have to determine the angle of the inclination at which the system will start sliding. Next, we will draw the free body diagram and we will try to understand the equation of motion. So, as usual, we will draw the free body diagram. Uh, First, we define the directions. X is up the incline and y is perpendicular to the incline. You can take any other convenient directions. Next, the free body diagram for block 1. So m1g sine alpha down the incline, m1g cos alpha perpendicular to the incline. Tension by the string is uh, above the incline, that is up the incline, and n is perpendicular to the incline. Similarly for block 2, if we draw the free body diagram, the component of weight down the incline, m2g sin alpha, this one, m2g cos alpha perpendicular to the incline, that component of weight. Friction here up the incline, here also friction f1 up the incline, and normal reaction n2 perpendicular to the incline. Okay, next, one thing that we have to understand, that as the block starts sliding, since this has less coefficient of friction, it will have more coefficient of friction. Therefore, if this block reaches the angle of repose, since this will not reach the angle of repose because coefficient of friction is more, therefore it cannot slide. Therefore, one thing that we have to understand is that once this block starts sliding, this will also start slide. Therefore, their impending motion condition in this case will reach at the same time, that means simultaneously. Therefore, we can write that f1 is equal to mu s1 n1, f2 is equal to mu s2 n2. So, they will take place simultaneously for the same alpha. That means initially this will be ready for sliding, but m1 has to wait for m2 to get slide first, then it will slide also. So that is the physics that we have to understand, and therefore this condition will be satisfied simultaneously for this case. Okay, next we will identify the unknowns for this problem. So how many unknowns are there? Let us try to understand. For this case, alpha is unknown, we know, f1 or n1, because if I know n1 then I can determine f1, or if I can determine f1 then I can determine n1. Therefore, either f1 or n1 are unknown. Similarly, f2 or n2, one of them is unknown, another can be determined from these relations, and t is the unknown. So how many unknowns are there? 1, 2, 3 and 4. So 4 unknowns are there. Therefore, these 4 unknowns can be solved by constructing 4 equations. What are they? The equilibrium equations, or that is the force equilibrium equation for each blocks. So 2 equations for each blocks, therefore each block, therefore 2 into 2 4. So we can solve it. Therefore this is a solvable problem that we have to understand first. Then one thing that we have to understand is that these two blocks will start moving simultaneously, as I have just mentioned, because block 1 will not be able to move down as angle is just more than zero point 0.2. What is the meaning? That means according to angle of repose, if block M1 was there only, then as the angle reaches angle of repose, that is tan inverse zero point 0.2, the block M1 will start sliding. But since M2 is connected and here the coefficient is more, so it will not slide. Therefore M1 cannot slide without M2 being sliding. So next is, therefore we have to understand that therefore this condition has to satisfy. These two blocks will start moving simultaneously because block 1 will not be able to move down as angle is just more than zero point 0.2 or tan inverse mu s1, because at that instant the block 2 is not ready to move. That we have to understand. Okay. Next, therefore, what is tan inverse? What is tan inverse mu s1? Tan inverse mu s1 is equal to tan inverse 0.2, that is 11.31 degree. Tan inverse mu s2 is equal to tan inverse 0.3, that is 16.7 degree. Okay. Next, if we write the equations, that is summation fx is equal to 0 and summation fy is equal to 0 for these two blocks, that means from the free body diagrams of these, then what we can basically do is we can start writing in terms of the unknowns. So here first I will write the y equation, because there the number of variables or number of terms are less, so I can easily replace from them in the x equation. So summation fy is equal to 0 for block 1, this one n1 minus m2 m1g cos alpha is equal to 0, so n1 is equal to m1g cos alpha. Okay, therefore in the x equation, if I try to write, so that is t in the positive direction, t plus f1, this one, so t and f both are positive in the positive direction, and m1g sin alpha is in the negative direction, so t plus f1 minus m1g sin alpha is equal to 0. That means at the condition of impending motion. Therefore t I can determine. Why I am determining t? Because from this I will determine t and I will replace t for the block 2, because t I have not been asked to determine, means final solution is not t, so we will replace or eliminate t from block 1 into block 2. That is the uh, strategy of the solution. Okay, next, so we can calculate t in terms of mu s1 and alpha. So m1g sin alpha minus s1 m1g cos alpha. Okay, because n1 is this one. Okay, next we will rewrite this and we will try to see in terms of force for cause of motion down the incline. What is the force that causes motion down the incline? That is m1g sin alpha. Okay, you see this one, m1g sin alpha. Now that is equal to what? T plus mu s1 m1 g cos alpha. Now try to see the difference between this system and a system where only m1 was there. That means the simplest problem where only one mass is there down an incline. In that case, T will not be there. Simply this will be there. Therefore, you can see if we try to calculate alpha from this, it will be definitely more than tan inverse mu s1, because here this extra term T by m1g cos alpha will be there. That means if I divide both sides by m1g cos alpha, then it will be mu s1 into mu s1 plus T by m1g cos alpha, and on this side it will be tan alpha. So alpha will be tan inverse of T by m1g cos alpha plus mu s1. So it will not be simply tan inverse mu s1. It will be something more than that. So that we have to understand. Okay. Therefore, that that is more than that for the self weight of the block. For the self weight of the block, the cause for motion is m1g sin alpha, but there tension was not there, and therefore the angle in case of the block that was moving by self weight, that means when m2 was not there, in that case m1g sin alpha would have been balanced by mu s1 m1g cos alpha, but here this tension is extra. Therefore that alpha at which it will start move at which it will start to move will be definitely more than angle of repose for this particular condition, that is tan inverse mu s1. So alpha must be more than tan inverse mu s1. That you have to appreciate. Okay. So let us try to see. Therefore, m1g sin alpha has to overcome not only the frictional resistance. Try to understand. m1g sin alpha not only need to overcome the frictional resistance, it has to overcome the pull from the other block, that is T. So m1g sin alpha now need to overcome not only this part, it has to overcome this part also. Therefore, it is expected that the angle alpha should be more than tan inverse mu s1. That means simply angle, it should be alpha should be more than angle of repose for mu s1, that is 11.31 degree. Following similar logic, you can show that the angle alpha should be less than tan inverse 0.3 also. Why? Because in this case, if you see that now m1 m2g sin alpha and T both are trying to overcome the frictional resistance. Therefore, for this m2, now it will be easier for it to overcome the frictional resistance, because along with the self weight m2g sin alpha, tension from block m1 is also helping it to overcome the frictional resistance. Therefore, for this situation, that is the combined situation m1 and m2, the angle alpha at which the block system will start to slide should be less than the angle should be less than the angle of repose corresponding to mu s2. So it should be more than the angle of repose corresponding to mu s1, and it should be less than the angle of repose corresponding to mu s2. That means what? It should be more than this but less than this. That means the angle alpha for this situation at which the block will slide will be in between this 11.31 degree and 16.7 degree. It will be in between. So high, it must be clear. Okay, if you do not understand, then you please listen from uh, the beginning of this part, and I think it will be easy to understand. Okay, just follow these equations, that is m1g sin alpha is equal to t plus this. So initially it has to overcome only this for single block, but for double block you have this extra part, so alpha should be more than 11.31 degree. And in the same way, if you try to see the m2g sin alpha plus t is equal to f2, so now m2g, that means friction will be now uh, battling, or it will be overcome by both m2g sin alpha and t. So it should be, therefore alpha should be less than angle of repose. Okay, whatever. Next we will try to see the equations for block 2. So that is fy is equal to 0, that means summation fy is equal to 0, that gives n2 minus m2g cos alpha. So for this, n2 minus m2g cos alpha is equal to 0, and summation fx is equal to 0, so it will be n2 is equal to m2g cos alpha. Summation fx is equal to 0, that gives f2 minus t minus m2g sin alpha, f2 minus t minus m2g sin alpha. So f2 in the positive x direction, tension in the negative x direction, and m2g sin alpha in the negative x direction, therefore their sum, algebraic sum, is 0. f2 is equal to mu s to n2, mu s to n2, minus what is t? T I have replaced from this here, so it is m1g sin alpha minus mu s1 m1g cos alpha, that I have replaced here. So plus, it will be minus minus plus, so mu s1 m1g cos alpha minus this, minus this one m2g sin alpha, so minus m2g sin alpha. So f2 is equal to mu s n2, t is equal to this minus this, so that is plus because of minus, and m2g sin alpha, it comes here. Next, I have written n2 in terms of m2g cos alpha. So mu s n2 is equal to mu s2 m2g cos alpha minus m1g sin alpha plus mu s1 m1g cos alpha, that is plus here, and minus m2g sin alpha is equal to 0. Now we have collected the g cos alpha and g sin alpha terms. So g cos alpha, so it will be g cos alpha multiplied by m2 mu s2 plus m1 mu s1, and g sin alpha terms, so it will be m1 plus m2 multiplied by g sin alpha. From that we can determine what is alpha. Alpha is equal to tan inverse of mu s1 m1 plus mu s2 m2 divided by m1 plus m2, and this is m1 plus m2, so it will be alpha is equal to tan inverse of that. I have done it just skipping one step, so g will cancel and alpha will be tan inverse of this. Okay, so that is your final answer. Now in this problem it is told that m1 is equal to m2. So simply you can take m1 out from this, so m1 is equal to m2, so m1 can be taken common, and m1 plus m2 is equal to 2m1, so it will be simply that m will cancel, so it will be mu s1 plus mu s2 by 2. here m1 plus m2 is equal to 2m1 or m for whatever. So it will be mu s1 plus mu s2 by 2. So you can see that this is average. As I was telling that it is more than tan inverse mu s1 and less than tan inverse mu s2. So if you put the values, then it will be tan inverse of 0.25 instead of 0.2 and 0.3. So you can see if I calculate the angle, then you can see if I calculate the angle, then it will be 14.04 degree. So you can see that this is in between the tan inverse 0.2 and tan inverse 0.3. Okay, so for this system, when you have the same mass blocks, now they will start sliding at an angle which is in between the angle of repose for individual coefficients of friction. Okay, so for your problem it is this much. Another insight that I want to give additionally is that if, that means this is the final value or expression for alpha, that is the angle, that is tan inverse of mu s1 m1 plus mu s2 m2 by m1 plus m2. Now one condition can be thought that when m1 is much more than m2, so in that case what will happen? If m1 is much more than m2, then m1 plus m2 is almost equal to m1, because compared to m1, m2 is negligible, so it is m1. Therefore we can write that mu s1 m1 plus mu s2 m2 by m1 plus m2 is equal to, so m1 plus m2 is equal to m2 almost, so m1 will cancel, and mu s2 m2 by m1, because it is m2. Now since m2 is much less than m1, therefore it will be almost 0, therefore it is mu s. So that alpha, that means this part is mu s1, therefore alpha will be tan inverse mu s1. That means you consider this case when m1 is much more than m2, therefore the alpha for slip will be equal to the angle of repose for the coefficient mu s1. Okay, in the other case, other extreme, when m1 is much less than m2, in a similar logic, following the similar logic, you can show that alpha is equal to tan inverse mu s2. That means when m1 is much smaller compared to m2, so this object will start sliding when the angle alpha is equal to tan inverse mu s2. That means this condition for m2 will be dominating instead of an average. Okay, so that is the additional insight that I wanted to give you along with the solution. Okay, I guess you have got a nice concept from this problem. Thank you for watching.